Introduction to electricity. You don't know what electricity? You know what electricity is. Did I put deodorant on? I did. Okay. We're okay. Let's do this. All right. Yeah. Let's talk about electricity at its basic form, at its basic definition, is just the movement of electrons between atoms. We get all of these. We get light, we get heat, we get sound, even we get motion, all from the movement of electrons. It's electricity. It's very nice. Look at that. Her hair is crazy. She's a crazy lady. Yeah. In the actual PowerPoint, there's a bunch of slides in between this. But we don't really need to talk about that because we never do any calculations with atoms or protons, neutrons, and electrons. The big idea is that electricity is just moving electrons around. That's how we get current. Current is just the flow of electrons. What makes good the whole explanation in the PowerPoint is trying to tell you what elements are good conductors and what are good insulators. Conductors are elements where the electrons can move freely. So like their outer layer has few electrons, so they can pass between each other. Insulators, they have almost a full outer layer of electrons. I don't know what you call outer ring, whatever. Those are the valence electrons. They have a lot of electrons, or they're close to being full, and so they want to keep theirs, and you can't really move the electrons around. That doesn't really matter too much, but conductors usually are like metals. Most metals are good conductors, but like plastics and other things, those are not good conductors. So that's what we have here. Just picture. Look at this metal. Look at that. This is a conductor. Copper is a good conductor. It has one valence electron, so it can kick around the electrons really, really easily. Things like wires, they're coated with insulation. They're coated with not metal, so that they don't conduct, so that you don't lose the electron flow in the middle of your circuit. Let's talk about circuits. Ooh. First of all of this stuff, it's good to know. We'll talk more about it. But in terms of circuits, because that's what we're going to be dealing with, that's what we're going to be playing around with. Hopefully, we'll actually be playing with it physically, but we might actually use a simulation if I can't find all the components in the other room. So the definition of an electrical circuit is just a system of conductors and components forming a complete path for current to travel. Usually you have a battery, and then current flows through either you have some resistors and then back to the battery. It's a complete path. If the path is broken, it's not an electrical circuit. The circuit is broken, so it's not a complete circuit. So that's the definition of an electrical circuit. The properties of an electrical circuit include volts, amps, and ohms. Voltage is, I'll write that definition right now. The actual definition of voltage is the amount of potential energy between 2 points on a circuit. But that kind of doesn't make sense to me, or it's maybe to you. I don't know. We can think of voltage as there's a good analogy. Is that the next thing? Yes. I actually did decide to write it down. So, voltage, by definition, is the amount of potential energy between 2 points on a circuit. I'm going to say, think of it as pressure in like a water tank. That's the analogy that we're going to be using. No, I don't want to go to that. Wait a minute. Pause this. Thought I was missing a slide, but I'm not. Okay, so voltage is measured in volts. That's convenient. It's denoted by V. That's this stuff. Current you can measure as like the flow. Well, no, current is the flow of electrons. So I'm going to find somewhere to write this. So these are probably things that you should write down. Voltage. You can think of it as pressure. I'll get to that analogy in a minute. Current is the flow of electrons. Sorry, it's the flow of electrical charge, and the charge is moved by the electrons. So it's kind of closely related. So current is a flow of electrical charge. You can think of current as the amount of water flowing through a pipe. I'm going to get to this analogy in a minute, but just current is like the amount of flow, the amount of stuff that's flowing. So, yeah. If you have a lot of current, if the current is really, really high, then it's like a lot of charge is flowing through, whatever wire that you have. If the current is very low, then there's a little bit of charge flowing through the wire that you have. Current is measured in amperes. No, I mean amps. Well, is that the same thing? Yes, those are the same thing. Amperes are the same thing as amps. Is amps for short, denoted by A. And resistance, huh? Resistance also has a pretty technical definition. 1 ohm. Well, let's just say that the resistance is like the rate that current can flow. So if a wire or some piece of a circuit has a high resistance, then current can't flow through that well. So current would decrease. It would be small. If it has a very, very low resistance, current can flow through it very easily. So it'd have a higher current. Charge, the rate at which charge can flow. That's not really the definition, but that's how I'm going to think of it. That's how you should think of it. This one's kind of a long explanation. So resistance is the rate at which charge can flow. It's kind of maybe like you can think of it as a restriction. Like if you have a smaller pipe, the water can't flow through it as much, as quickly. But the idea is that circuits with higher resistance, so the more resistance you have, the less charge can flow through it. So circuits with high resistance have less flow, which means less current flowing through it. So that's what that means. Write that down. Resistance is measured in ohms, represented by the Greek letter omega. Yeah, it looks like a horseshoe. Let's get to this analogy. So, say we have a battery, and that battery has a voltage. The voltage, remember, you think of pressure. So if we have a tank of water, that's the battery, and the water inside, you can say, is like the charge of the battery. The pressure in the tank is the voltage. It's the potential energy. It's how much, if you have a really, really high pressure, you can push out a lot of water, or you can push out a lot of current. The piping you can think of as wiring, and anything that's like powered by the piping. Say you have a light bulb, that would be a resistor. So that would be something that resists stuff. So the current would flow through. This would decrease the current if you have more items on your piping, or on your water, or on your wire. Sorry. So let's review this, and then I'll start this in the next video. So the voltage you can think of as the pressure in the water tank. The charge you can think of as the water, the actual water. If there's less charge, there's less water to flow out of the tank. The wiring could be the piping. The current is the flow of the water. So if a lot of volume of water is flowing through the pipe, that corresponds to a high current. And the resistance is like something that decreases the current or increases the current. If it has a low resistance, the current can be really high. If it has a high resistance, it decreases the current. Let's just go over this slide real quick. Okay, so current is the flow of electrical charge measured in amps. We already talked about that. When the faucet is switched off, is there any flow? No. So if I switch this off, then there is no current. There's nothing. It's not connected to anything. So there's no more current. If the circuit is broken, that's what it means. If the switch is off, then the circuit is broken. There is no more current because it's not flowing anywhere. When the faucet is switched on, is there current? Yes. So hopefully that makes sense. You're thinking of current as the flow of water through this. This is a long video. I'm going to stop it right now.